What's going on, guys? Back at it again with another video. In this video I'm going to be teaching you how to calculate double mini difficulty. We're going to be going through a three-step algorithm similar to trampoline, except in this algorithm, because of step number 2, our numbers are going to be quite a bit bigger than trampoline. So the first step in the algorithm is we're going to calculate a half a point per flip and 2/10 of a point per half twist. The second step is we're actually going to multiply this sum times the number of flips. And the third step is we're just going to add on a pike bonus of 0.4 and a straight bonus of 0.8. So let's go ahead and calculate a couple of these. A double back tuck, step number 1, a half a point per flip. That's going to be 1 full point. 2/10 per half twist. There's 0 half twist, so we're going to have plus 0. Then we're going to multiply by the number of flips, which in this case is 2. 2 times 1 is 2.0, which is our total difficulty for a double back tuck. A double back pike is going to be the same calculation, half point per flip times 2 is 1.0, plus 0 for the half twist, times 2 for 2 flips. Step 3 this time, we're going to add on 0.4 because it's in the pike position. That puts us at a total of 2.4, quite a bit bigger than its difficulty on trampoline. Next we'll go to a half out tuck, a half a point per flip, 2/10 per twist. We're going to start with 1.0 plus, this is the first time we see a 0.2. We're going to multiply by 2. Since it's a tuck, we're not going to have any bonus, so that puts us at 1.2 times 2 is 2.4, same as a double pike. Next is a Rudy out pike. It gets a little bit more tricky. We start with 1.0 plus, now we have 3 half twists. 3 times 0.2 is 0.6. Then we're going to multiply that by 2. Then we're going to add 4/10 for pike. 1.6 times 2 is 3.2 plus 0.4 is 3.6. Which is the difficulty for a Rudy out pike, getting really big compared to what it is on trampoline. A half-half triff tuck. This one is cool because we're going to multiply by 3 in step 2. So we start off with 1.5 plus 0.4 because there's 2 half twists, 1 in the first flip, 1 in the third flip. Then here, step number 2, we're actually going to multiply by 3. Then we're going to add 0 because it's a tuck position and not pike or straight. 1.5 plus 1.4 is 1.9 times 3, 5.7 for a triff tuck. That's a big difficulty. And finally, a full straight. We're going to start with our 1.0 because it's a double. Then we're going to add 4 times 0.2 is 0.8. And we're going to multiply by 2. 1 plus 0.8 is 1.8 times 2. Is 3.6 plus 0.8 for straight is 4.4. So just as with trampoline, there are a couple exceptions to the rule. The rule always works for calculating double, triple, and quadruple somersaults, but for singles there's going to be a couple exceptions. So for example, the back or front tuck, pike, and straight go 0.5, 0.6, and 0.6. You don't get an extra bonus for doing a back straight compared to a back pike. All brannies, similar to trampoline, are going to be 0.7 regardless of the position. And then your back full is going to be, as you expect, is 0.9. But then when you add a half twist, instead of adding 0.2, you're going to actually add 0.3. Then another 0.3 for your double full, then your Randy's going to be 0.4, 0.4, and then 0.5, 0.5 going up to your Adolf and your quad full. Don't ask me why, because I have no idea why this is the case, but it makes sense that the quad full should be quite a bit higher, for example, than the double full, because it's not twice as hard to do, it's significantly more than twice as hard to do. I hope you liked the video. Leave me a comment if you have a question about how to calculate double mini difficulty.